So hello students, look at the experiment, and this experiment is for the students of BTech first semester and BSc first semester students. So what is our experiment? To plot a graph between the distance of the knife edges from the center of gravity and the time period of a ball pendulum. We have to draw the graph between the knife edges of the center of gravity and the ball, and from the graph we have to calculate the acceleration due to gravity. So what are the basic apparatus we need here? We have a need a bar pendulum, we need a stopwatch and wooden wedge and a meter scale. What is the theory of this practical? As you are seeing here, that the theory, the graph is plotted between the distance of knife edges from the center of gravity along x-axis like this. This is the graph. Here we have to draw the graph. Here I will take the one side of knife edge, here I will take the another side of knife edge, and this is the bar pendulum. So from y-axis, the shape sharp of the bar is shown in the figure. A horizontal line ABCD is drawn which cuts the graph at ABCD. That means it cuts the graph at ABCD. Similarly, A prime, B prime, C prime, D prime. So where the pointers A, C and BD lies on opposite side of center of gravity distances, and we use here the formula T is equal to 2 pi root of L by G. Now on squaring we get it, T square is equal to, I will write here, we get it, T square is equal to 4 pi square root of L by G. So I will shift to G here, so we get here G is equal to 4 pi square L by T square. So what is the procedure of this experiment? Firstly, we have to find the center of gravity of a ball pendulum by balancing it on a wooden wedge and mark the two ends A and B. Then we have to place the knife edge in the first hole on either side parallel to each other and mark them tight so that sharp edges pointing towards the center of gravity, so that these become irregular. Now we have to count 20 vibrations on both sides and note the time taken, the mean, and find the time period of vibration. Point number 4, now suspend it on the edge on side B and repeat the observation as below. Now we have to measure the distance between center of gravity and the inner edge of the knife edge from side A and side B. Similarly, we have to repeat the observation with knife edges, all the holes and both the sides of pendulum. Now we have to draw the graph between the distance and time period and find the value of L and T to determine the value of G. So dear students, as you are seeing that this is the ball pendulum, and we have a certain number of holes in this ball pendulum, like we have hole 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are total number of 19 holes in this ball pendulum, and the 10th hole here we take it as a center of gravity, and from this hole to this hole the distance is 5 centimeter. Similarly, here the distance is 5 centimeter, here the distance is 5 centimeter, here it is 5 centimeter, here it is 5 centimeter. So we have a total number of 9 holes below the center of gravity, and we have also the 9 holes above the center of gravity. And we have two knife edges here, and this is knife edge 1, and here at the middle it is, here at the top there is another knife edge. And we should keep in mind that the V shape of this knife edge should be hanged with this wedge, so that there should be the less friction of this pendulum. And we have to actually take the time period for the number of oscillations, and here we will take the time period for 10 oscillations. Now I will count here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now we will reverse this pendulum. Now I have to take the time period for 10 oscillation on this side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have to note down the timetable or the time on the table. So we will do the same experiment. We will shift this knife edge into another hole, and consecutively up to this point, consecutively we will consecutively on the other side, and we will note down the time period for the whole pendulum. And after that we will draw the diagram, we will draw the graph, distance versus time. So dear students, here you are seeing that we have taken the reading in the form of a tabular form. So here it is a distance 5 centimeter from the center of gravity, and the total number of oscillations is 20 and the time period is 54. So for one oscillation the time is 2.7 seconds, and for 10 centimeter it is 39. Number of total oscillation is 20 and the total time is 39, and for one oscillation the time period is 1.59. Similarly, we have taken the readings here for one side, and this is the reading from one side, and now we will draw the graph from this reading is here. The graph comes out to be like this. Here this line will represent the time axis, time that is measured in seconds, and this represents the distance from one side of the ball pendulum and from another side of the ball pendulum. And from this graph we will calculate here the L, that is the effective length, and that L is equal to here. If we see the value of L will be here equal to, that is we have to calculate here, G is equal to 4 pi L divided by T square. So T we can calculate here. Now L is here, that L will be AD plus BE divided by 2. That means AD. So here the point is 35. I will take here A is equal to 35, AD 35, and D it is 20 plus 20 divided by 2. So from here we will get the value of L, and we will substitute this L here. So we will get the value of G here, approximately 9.8 meter per second square. I hope dear students you have got the idea of this experiment very well. If you have any question, if you have any doubt, if you record this video, you will post your comment, you will post your doubt in the comment box. Hope you have understand this well. Thank you dear students, wishing best for you.